being pulled across the floor at an angle with a force of 85 newtons. And it's our job to figure out what the acceleration of the box is going to be as a result. So we're going to figure out, okay, which way is this thing going to accelerate? It's going to accelerate toward the right. So I'm going to come up with my equation along the x-axis toward the, with the right and the left directions. So I would take my positive or right arrows minus my left arrows. Now I already broke my orange angled 85 Newton pulling force into the force in the x direction and the force in the y direction. So now I'm going to write those down. Because when I do my equation along the x-axis, I've got the force of pull in the x direction minus the force of friction. And that's going to give me the mass times the acceleration of this object. Now the algebra is pretty easy. If I want to solve for acceleration, I just have to divide by the mass. So my left side remains almost unchanged. Force of pull in the x minus friction, but I divide the mass over to that left side, and that would give me acceleration. Now ideally I can plug in some numbers. Force of pull in the x direction is the adjacent side of this triangle. So I'd use cosine of my angle times 85, and that would get me force of pull in the x. But the problem is with friction. Because while force of pull in the x is easy enough to get, cosine 40 times 85, my force of friction, I need the coefficient times the normal force. And then I can divide that by my mass, which is 15 kilograms. Now I know the coefficient is 0.3. I have that, but I do not have the normal force. We have to solve for the normal force before we can move on. So hopefully you realize this box is not accelerating up, and it's not accelerating down. It's not accelerating at all in that up and down direction. Therefore, there's no A for the add up all the forces equals ma. So this is one of those situations where I take my up arrows, normal force pull in the y direction, and they're going to equal my down arrow, which is force of gravity. So that's where this equation comes from. My normal force up plus force of pull in that y direction, so the force up, is going to equal my force of gravity pulling down. Now to finish solving for my normal force, I just have to subtract that force of pull in the y direction to the other side. So my normal force is equal to force of gravity, which is the mass, which is 15 kilograms, times 9.8 meters per second squared, minus that force of pull in the y direction, and that's the adjacent side, the opposite side of this triangle, so I'm going to use sine. Sine of the angle, which is 40 degrees, times the mass of this box or block, which is 15 kilograms, times 9.8 meters per second squared. And when I plug all of that into my calculator, I get a normal force of 92.36 newtons. Now I can plug that in right up here, and I can get my answer. So I still have the cosine, 40 degrees, times the hypotenuse force, which is 85 newtons, minus my coefficient, which is given at 0.3, times my normal force, which is 92.36 newtons. Divide all of that by my mass of 15 kilograms, and that should give me my acceleration. And when I plug all that into my calculator, I get an acceleration of 2.5 meters per second squared.